competition time. Who can see the mistake I've made in this schematic and on my PCB layout? The clue is here. So pause the video now, go into the comments and write down what you think the problem is. Well, hopefully you got it right. If we look at the datasheet for this RGB LED, you can see this is common anode. I've done common cathode. So pin 2 here shouldn't be connected to ground, it should be connected to 3V3. So looking at my PCB layout, originally I was thinking, well, maybe we can just cut through the copper and isolate this pad, but I think that's not really going to work. So what I'm going to do is I'm going to desolder the LED, cover this pad in solder resist, solder the LED back on, and then we'll just run a quick little wire from here to here, and then hopefully our LED should start working. So let's get over to the bench and give that a go. So I was going to use my hot air gun for this, but then I thought actually it's probably better to use the mini hot plate. There is a bit of plastic around, we've got a little button here, and there's plastic on the module. So let's use the mini hot plate to melt the solder and extract this. So hopefully the hot plate is working. It does seem to be heating up. Let's see if it melts the solder. Oh, there we go. That was fairly straightforward. Let's try not to lose the LED. So next step, I'll clean up these pads and then we'll try the solder mask and then we'll put it back on, see what happens. Now, of course, we have to say thanks to PCB Way for the fantastic PCBs. Did an amazing job as always. All the mistakes are my own. So check out a link in the description. Okay, let's add a bit of flux. And then we'll just clean these pads up. So I've got my solder wick here. Okay, that's looking pretty good. Nice and clean. And then finally a bit of IPA, 100%, just to do the final cleanup. So that's looking pretty good. So what we need to do is cover up this ground pad with some solder resist. Now we have to be very careful here because we want a very thin layer of solder resist, but it needs to be thick enough that we do get some insulation. So I've got a very fine paintbrush here. Let's try dabbing some on and make sure we don't get it too thick. So I think that looks pretty good, not too thick. Okay, so that should be nicely cured now. Let's check it. Yeah, seems pretty solid. And hopefully, if we place the LED back on, should be fairly flat, so it should go back nicely into position. So I think that looks okay. Yeah, so next step, let's put some solder back on these pads. Okay, so that's the pads with some nice bit of solder on. So let's chuck a bunch of flux on as well. Oops, lucky. Disgusting hair. Nice. So stick some flux on. Now we go back onto the hot plate and we'll try and stick our LED back on. Give it a bit of a nudge. There we go. Back soldered on. So let's turn off the hot plate. So a quick clean up again. Another wash with IPA. Get rid of that flux. And let's do a quick inspection of our handiwork. So it looks like that's good. That looks good as well. So nicely soldered back on. So our next challenge is hooking up from this pin here onto our 3v3 pin, which is this second pin here. So let's do that. I've got some very fine 0.2 millimeter wire. So hopefully we connect from there, pin 2, all the way through to there. So this should be doable. Right. Okay. I think we're there. Yay, we are connected. Good grief. In all honesty, I can only describe that as a traumatic experience. I have no idea how people like Stev Fixes does this so easily. It's a nightmare, but it's done. It works. So that's good. LED lighting up.